coming. I particularly welcome our MA and PhD students, our new students. So thank you very much for coming also. And well, it is my pleasure to welcome you to our 2023 Lectio Inauguralis for the postgraduate in philosophy, including the master's program and the PhD program. So please feel at home, and we're going to have a great journey into deep questions. So let's go now. I want to introduce our main speaker, Uljana Feest. She studied psychology, philosophy, and history and philosophy of science in Frankfurt, Bristol, and Pittsburgh. After completing her psychology degree at the Goethe Universität in Frankfurt, she worked for a couple of years as a researcher in an interdisciplinary project at a Frankfurt-based research institute, the Institute for Social Ecological Research. Before taking up graduate work in philosophy of science, from 1997 until 2003, she was a graduate student at the Philosophy Department and the Philosophy of Science Department at the University of Pittsburgh, completing her dissertation, Operationism, Experimentation, and Concept Formation in August 2003. From 2003 until 2006, Uljana was a researcher at the Max Planck Institute for the History of Science in Berlin, and then she held a position as an assistant professor at the Technische Universität Berlin from 2006 until 2012. She has been a visiting researcher at the University of Pittsburgh, the University of Michigan, and the Max Planck Institute for the Human Development, Berlin. Since March 2014, she is professor of philosophy at the Leibniz University of Hannover, where she holds the chair for the philosophy of social science and social philosophy. Her research is located in the intersection of philosophy of experimentation, philosophy of psychology, the history of 19th and 20th century philosophy, and some aspects of the philosophy of mind. In her research, she focuses on the ways in which methodological and conceptual questions are entwined in the investigative practices of psychologists, and on how this was debated from the mid-19th century until today. She is currently completing a book manuscript entitled Operationism and the Epistemology of Discovery in Experimental Psychology. And she has recently started working on a new project about the history and the theory of personality research. So please welcome Uljana, and she's going to talk about big data and machine learning in the measurement of the personality traits. After Uljana's talk, Anja Loechem, our PhD student, will make some comments on her work. Probably you all know Anja, but Anja is a PhD student here at the Alberto Hurtado University Philosophy Department, and she is deeply interested on issues concerning consciousness, the nature of consciousness, the function of consciousness, and also in the philosophy of artificial intelligence. So thank you very much for coming, and Uljana, all yours.
Thank you very much. I think I'm going to go over there so that the people sitting there can see me. It just requires gathering my stuff. Thank you very much for the introduction, and thank you very much for inviting me. I'm very excited to be outside. I'm very excited to do something else. Did I turn it off after there's a bubble? I thought I could just. Oh, it was working. Is it working? I don't think it's. Thank you so much. I'm going to. I'm not connected to my computer, but I'll open it so that I don't have to turn around all the time. That's a little loud. That is right, too much stuff. Thank you. So yes, the title is Big Data and Machine Learning in the Measurement of Personality Traits. And as you just heard, I am starting a new project I'm interested in research on personality. And as a historical phenomenon, when did people start thinking about personality? How did people conceptualize it? Why was it interesting? How did they measure it? And I think it's a very exciting project because there are so many different questions one can ask. And one thing that recently came up was the fact that I noticed, or my attention was drawn to the fact that machine learning methods are, as of recently, being used in research in personality psychology. I have too many different things going on here. So personality psychology, I'll just start with a very brief description of what personality psychology is. It studies inter-individual differences, and as such, it belongs to a field called differential psychology, which also includes intelligence. So personality research and intelligence research are two different fields, but they both belong in the field of differential psychology, psychology of inter-individual differences, as opposed to general psychology, which studies general functions. Historically, there have been various different approaches to studying psychology, thinking about it, studying personality, thinking about it in terms of types of personalities, traits that personalities can have, conceptualizing personality in terms of different motivational styles, different skills, and also approaches that think of personality kind of as something that develops over a lifetime and as something we construct in narratives. I'm not going to be focusing on this. These are all really interesting areas. I will focus on one particular approach that is pretty much the best known, best established one within mainstream personality research, namely an attempt to identify and measure a limited number of personality traits or factors or dimensions that we all share, but we differ in where we fall on those dimensions. So the idea is even though it's psychology of inter-individual differences, there is something we share in common, namely these five big dimensions, and the inter-individual differences are explained by how that we have these different, that we have different personality profiles, basically. So the best known and well-established theory of personality factors or traits or dimensions is the so-called Big Five model. And I've just given you a few, like the five dimensions are called neuroticism, extroversion, openness to experience, agreeableness, and conscientiousness. And because they're dimensions, there's obviously always one side of the scale and then the other extreme. Now, with the rise of machine learning data, the machine learning methods, as well as the availability of big data, people in personality research started getting interested in using those data and using those new available methods to further personality research. And so we see the emergence of a new field called personality computing or machine learning personality assessment. And what they do is they use deep learning methods or language models to analyze data that they get from social media use. For example, likes and follows on Facebook, but also automated analyses of social media language or automated analyses of the kinds of words or phrases people use in text messages. And the interesting thing is that apparently when you do that and apply certain mathematical or statistical methods, you get something like the Big Five. So people got very interested in this and excited about it because it promises, if you use these kind of data and then use machine learning methods, it seems to allow researchers to record everyday behavior in their kind of original, in their real life settings. So you don't have to put people in a lab, you don't have to give them questionnaires, you get these data, these likes and follows kind of in vivo. And so as a result, people or not as a result, but that is one reason why people are really interested in using this method. And the question from a philosophical point of view is, well, from a methodological point of view, clearly within psychology, but also from a philosophical point of view, is how should these personality computing models be assessed? What should we make of them? And conversely also, what should we make of, what exactly are they measuring? And I think that's also where it is kind of slightly more philosophical. And as I will explain, I think the two questions are actually closely related. What I want to argue is that personality computing models of personality are really a kind of measurement tool. And in psychology, there is a long tradition of thinking about measurement tools and how to assess them, how to assess the quality of them as measurement tools. In psychology, the term that is used in that context is validity. So the question is, do these measurement tools have validity, which is commonly taken to mean, how do we know that they really measure what we think they do? But there's also a different question, which is, are they useful as a research tool? So what I want to do today is, first I'll give a brief history of the psychology of personality traits, very, very brief, just and very selective. I'm so sorry. This is what happens when I'm, yes, my apologies. Thank you for, please do that again. Okay, I'll try. So maybe I should just, I don't want to turn away from you. That's why I'm looking at my screen, but then I forget to notice that I haven't. Okay, we're right here. I'll start with a brief history of the psychology of personality traits leading up to the Big Five, and then I'll explain received notions of validation to you, because that's a central concept to assess measurement procedures. And then I'll talk about the question of whether the Big Five, prior to the emergence of big data models, had construct validity, another term I'm going to explain, and then we'll turn to the question of whether the machine learning models can be said to have construct validity, and then I will move beyond that to ask, can these models further our knowledge of what personality is? My main theses are that the personality computing models of the Big Five at this point seem to possess, well, a certain degree of construct validity. I actually have to qualify this a little bit later. But there are discussions in psychology concerning their utility for construct development. So the question is, what can they do for us if we actually want to understand better what personality is? And that's the point where I'm saying there are wide open questions there. Wait. Let's start with a little bit of history. And as I said, this is very selective, but one name in the history of psychology that many of you may have heard is Carl Gustav Jung, who wrote a book, I think it came out initially in German in 1921 and was translated into English in 1923, called Psychological Types. And in this book, he distinguished between the introvert and the extrovert. He also introduces the idea that there are various psychological functions, thinking, feeling, sensation, and intuition, and that depending on whether you're an introvert or an extrovert, and depending on how pronounced these different functions are in you, you're going to be a very different type of person. And he also, this is underwritten by of course, his particular brand of psychoanalysis, and he uses it as a clinical tool. So he thinks he can diagnose what kinds of problems people are going to have based on, or he can diagnose them and explain why you see particular mental disorders based on their personality types and these psychological functions. Now, a little more than a decade later, Gordon Allport published a book, Personality, A Psychological Interpretation. Allport is commonly regarded as one of the founders of a mainstream academic empirical work on personality. And he's a really interesting figure, and even though he is kind of credited with being the one that made personality scientific, in quotation marks, he actually thought of personality in a very rich sense. He did not think that you could be reduced to something that can be measured. But nonetheless, I'm introducing him here because one thing he did is he took up Carl Gustav Jung's terminology, as did actually other people as well at the time. Jung was incredibly influential in the field of personality research, interestingly, but he introduced the notion of trait as opposed to type, saying that traits, and I'm quoting him here, traits are generalized and focalized neuropsychic systems, or are a generalized and focalized psychophysic system, neuropsychic system, peculiar to the individual, with the capacity to render many stimuli functionally equivalent and to initiate and guide consistent equivalent forms of adaptive and expressive behaviors. So depending on our traits, we have a tendency to respond in specific ways to, for example, environmental stimuli. And importantly, he says, people have traits and they fall under types. So for him, Jung's notion of a type it's basically just a classification device, whereas the notion of a trait is an explanatory device, right? You have a trait and that explains something about you. And so, according to him, now the question is, how do you identify the traits, right? I mean, it seems pretty commonsensical that we have traits and that they explain something about us, but how do you find out how many traits there are and whether you have them? And so that's what he took to be one of the tasks of personality psychology, to extract, quote unquote, common traits and kind of build a theory of personality around that. And in the book, he basically lists as you can see, thousands of trait adjectives in English, and tries to analyze them into groups of traits, into clusters of traits, in order to then come up with something that we now call factors or dimensions. Now, a little bit of background here. By the 1930s, personality psychology was adopting a method that came from intelligence research, namely Spearman's method of factor analysis. Factor analysis is a statistical method that promises to identify clusters of correlated trait descriptions and to attribute them to some underlying, more limited number of factors, so-called latent variables. So you have, what we in common English or Spanish or whatever, we have these descriptions of traits, thousands of them, but you can use factor analysis to attempt to reduce the number of traits to so-called latent variables. So where do you take the data from such that you can apply the statistical method? Well, you take it from self and peer rating questionnaires, which ask people to rate themselves and others. So you might give somebody a questionnaire where they answer questions. You say, well, how does this apply to you? I'll give you an example in a moment. Or you give them a list of adjectives and say, could you just say on a scale from 1 to 7, whether that describes you. And then you use the method of factor analysis to see if there are some commonalities, that certain traits correlate with one another in a way that such that you can attribute that correlation to a so-called latent variable. I promised I would give you an example, so here's a very early attempt to do this, Gilbert and Guilford. Notice this is actually before Allport published this book, so Allport isn't the only person, he's just the most famous one. Gilbert and Guilford constructed a questionnaire where they wanted to use factor analysis to see if you can get the introversion-extroversion dimension kind of represented. So you can see some of the questions. They have a series of 34 questions, and they ask things like, do you express yourself better in speech than in writing? Are you inclined to limit your acquaintance to a select few? Do you generally prefer to lead in group activities? And so the basic idea is these are questions designed to find out whether somebody's an extrovert. But then they did a factor analysis and found that even though you can force the data to just load on these two traits or these two factors. Actually, strictly speaking, it's one factor, right? But really, the data were more scattered than that, and so they posited that in addition there seem to be other factors, which they call, and here you can see you know, how then kind of ordinary language comes in, because now you have to name these factors. They said, well, let's posit there's also something called emotional sensitiveness, something called impulsiveness, and something called interest in self. Another big figure in the history of psychology, Raymond Cattell, used the lexical approach, which is not questionnaire-based, but like word-based, i.e. asking people to rate themselves or others. And he also applied factor analytic methods and came up with 16 factors. One thing about factor analysis is that you can do a lot of playing around, and it's to a certain degree conventional where you draw the line, when you say, well, I'm going to stick with these 5 factors, or whether you say, oh, maybe they're 6 or maybe they're 4. So Cattell came up with 16. Subsequently, nobody was able to replicate 16, and so people started saying, but I mean, I'm still mentioning him here because he is considered a really important figure, but subsequently people basically converged on 5 factors. And so here is a little representation. I don't know how probably you can't see this very well, so I'm just going to explain what's on the slide. This is an overview of some of the results between 1949 and 1986. So these are all studies that come up. I think in the second one only comes up with 2 dimensions, extraversion and neuroticism. Oh no, and he has psychoticism, so he has 3. Most others come up with 4 or 5, and they mostly give them kind of similar names. So that's the situation in 1986. And now the question is, well, how do we know that that's a good model? That's a good model of thinking about personality. And the reason, so in order to explain to you how psychologists thought about this, we need to introduce the notion of construct validity. So this whole thing, of course, takes place in a context in psychological research or more broadly in American society mostly, where people are becoming incredibly interested in testing. So psychometric testing becomes a big thing in applied context, in the clinic, in the educational context, in the forensic context, in the military context. And so people are given these tests, and it gives rise to the question more generally, how do we tell whether a test is good? How do we know that a test measures, actually measures what we want it to measure, or that it has any merit? And the American Psychological Association appointed a task force that thought about this question for a few years, and then came out with technical recommendations in 1952. And then in 1955, a couple of very kind of philosophically minded psychologists, Cronbach and Mehl, wrote a landmark paper that's still cited today called Construct Validity in Psychological Tests. One thing that is actually that is really worth noting here, and it might not come out very clearly in my talk, but I do want to emphasize is these people this is kind of foundational questions in measurement, are at the same time methodological and philosophical questions. And it's actually no coincidence that these people were thinking about it. They're in close contact with philosophy of science at the time. And you see it when you actually read these articles, that they're citing basically the logical positivists and their friends that had just immigrated to the United States, and they're obviously in close contact. So Cronbach and Mehl in this paper distinguish between various different kinds of test validity, namely content validity, predictive validity, concurrent validity, and construct validity. And I've highlighted construct validity because that's the one I mostly want to focus on. But I'll just quickly say something about the others. I mean, the others, or what's unique about construct validity is that it actually posits an attribute in people, kind of like Allport, who says traits are attributes of people, whereas the others are still more in the positivist tradition or in the behaviorist tradition, and don't really want to posit mental or internal entities, and instead say, well, for example, predictive validity and concurrent validity of a test basically just shows, to show that a test has predictive validity, you show that it predicts something. So you could have an intelligence test, and an intelligence test has predictive validity if it predicts, for example, school performance. But clearly, just because it predicts school performance, that doesn't mean that you measured intelligence. It is a measure of a test because it tells you that you can use it for something. But construct validity is really the new thing here. And the authors say that a construct is some postulated attribute of people assumed to be reflected in test performance. I always find that formulation a little not as clear as one might like, because I want to say that the construct is not an entity assumed to be reflected, but rather there's an attribute which is represented by the construct. So my take is what they're really trying to say is that when we use a test to measure, for example, introspection, we take ourselves to be measuring something that goes beyond the mere behavioral responses on the test, namely a postulated attribute of people, for example, a trait or a factor. Okay, and if that's what we want to do, we need to construct validate our test. We need to justify why we think that our test does that. Now, the interesting thing is that construct validation still to this day, I think, really refers to two interrelated problems. So on the one hand, of course, you want to validate your test. You want to make sure that your test tests what you think it does. But at the same time, you also want to validate your construct. You want to make the case that you actually have a good theoretical concept of, in this case, for example, introversion. So there is a problem here that some of you have already heard me mention a few times in the last few days, namely a circularity between trying to establish that introversion really exists and trying to establish that your test really measures it. And Cronbach and Mail and Hasok Chang, a philosopher of science at Cambridge, has called this the nomic problem. The nomic problem being how do you establish the kind of lawful relationship between an item and a test result, given that you don't have independent access to the item. Cronbach and Mail actually come very close to formulating a response to it, and they acknowledge the problem. They say we start out with a vague concept which we associate with certain observations. We then discover empirically that these observations co-vary with some other observations which possess greater reliability or is more intimately correlated with relevant experimental changes than is the original measure, or both. So they're suggesting that we start out with a vague construct, but that we somehow improve it in the course of our research. And this comes very close to something that Hasok Chang calls an iterative approach. You iterate between the concept and the measurement procedure, which then allows you to make better measurements, which then allows you to improve your concept. So in the psychological literature, there are two complementary approaches, or two ways, and I mean, Cronbach and Mail actually quite clearly say this. There's a correlational approach and an experimental approach. The correlational approach uses statistical methods to draw inferences about a trait. So the trait that we're trying to measure, we're drawing inferences. The experimental approach basically tries to rule out alternative explanations of the test performance, thereby trying to get closer to a better understanding of what we're actually trying to measure. Now, in theory, I think the two approaches should really go hand in hand. I mean, we start out with our data. We run statistical analyses that maybe provide some evidence that there really is a common factor for different data that explain these data. This is regression analysis, for example, but then we don't know whether there could be other explanations for the data. So then we should go and test these other explanations. Now, that's what I think should happen in theory. In practice, actually, the correlational approach has long dominated. And probably that's because the focus was always on test validation and not on construct development. So often in psychology, the reason why people validate tests is because they want to use them. So you have an intelligence test, you want to use it, say, in a clinical practice, or you have a test for a mental disorder, or you have something that you're using for, to select applicants for a job. You're not interested in, fine-tuning your understanding of the subject matter. You're just interested in, somehow classifying people into groups. And for that, so you're not interested in doing much with the test. You just want to know whether the test, as it is, works. So the classic go-to method in the correlational approach is laid down in an article by Campbell and Fisk, Convergent and Discriminate Validation by the Multi-Trait Multi-Method Matrix. And they argue that for a trait to have construct validity, the correlations of it should obviously read for a test to have construct validity. The correlations of the results of these tests with the results of other tests should be high, right? I mean, so if you have different tests that try to measure the same thing, the results should correlate, but the correlation with measurements of different traits measured by the same instrument should be low. Why is that? So for example, you have one instrument and you're measuring introversion, but also neuroticism. You want there to be low correlations because you want to make sure that whatever results you get are not caused by the instrument. That's called a method artifact. You want to make sure that they're actually caused by the thing that you're measuring, by the trait. So how did this get applied to the Big Five model of personality? So here's basically a study from 1987 that established that the Big Five model has validity and correspondingly that the measurement instruments they were using has validity. I'm going to quote them here. If the five-factor model is a reasonable representation of human personality, it should be recoverable from questionnaires as well as from adjectives and from observer ratings as well as from self-reports. So they're clearly using the multi-trait, multi-method approach here. Yeah, different methods applied to the different factors. And then they report a validation study in which they did just that. They used the lexical approach, a questionnaire. So the lexical approach on the one hand, a questionnaire approach on the other, and in addition they used self-ranking. So you had to apply the questionnaire and the lexical approach to your own person and also to different people, to a person that you know well. And they found that they found that this is basically the table that summarizes their results. The convergent correlations are given in bold, and you can see they're not super high, but they are a lot higher than the ones that are not in bold, and that's the discriminant validity. So that, I mean, I'm just kind of telling you, this is what in the psychological community constitutes good evidence that, at least on the correlation basis, that the Big Five model can be regarded as construct validated, and also the measurement methods they use clearly seem to work. However, the question is, what exactly do we learn beyond the fact that there are five factors? McRae and Koster actually acknowledged this in their article, quite clearly saying a growing body of research has pointed to the five-factor model as a recurrent and more or less comprehensive taxonomy of personality traits. And now I highlighted the next sentence because I think it's important. Theorists disagree, however, on precisely how to conceptualize the factors themselves. So in other words, we know that there are five factors and we have given them names, but we actually don't really have any idea what they are, or we don't have a theory of them. So we don't really know what exactly it is about people that make them score high, for example, on a particular personality dimension, and we don't know what's the underlying method. So what this shows is that there are different degrees or aspects of the validity of a construct First of all, the question is, do we have a tool to reliably identify a robust set of 5 traits? The answer to that seems to be yes, but then there are other questions, such as, do we have a good descriptive understanding of the ways in which these traits manifest themselves? And this is less clear. And finally, the question is, do we have a mechanistic account of why certain expressions tend to be correlated? Do we know, what makes somebody an introvert, such that there's a particular behavioral or emotional pattern in them? So it seems that in the absence of a sophisticated construct, correlational methods alone cannot address these last 2 questions. They can only address the first question. And so one question that I had going into this research is, well, what about the machine learning models? Can they do better? Now, in recent years, as I mentioned, there's been a lot of excitement about machine learning models, and one recent publication that I looked at distinguishes between different aspects of machine learning in relation to personality. One question concerns automated personality recognition. Can we use machine models to diagnose a person automatically? So how well can personality computing predict people's self-assessment? Another question is automated personality perception. The first one is predict people's self-assessment, so when they assess themselves, and the other is how well can it predict the way we assess other people. And the first one, which I've not highlighted because I'm not going to talk about it, even though many of you might think it's the most exciting of them all, is so-called automated personality synthesis, which concerns the question how well PC models can assist in the construction of artificial persons, which in itself might be kind of a contradiction in terms, but of course the idea is, can we build bots, kind of personality that are like robots, or at least, or internet bots. So, leaving that last question aside, a couple of authors that I'm citing here raise present the following result that already exists, namely automatic personality recognition and automatic personality perception increasingly result in above chance predictions of personality trait scores. So, apparently they replicate something that we can do. I take this to mean that personality computing models, or ML, machine learning models of personality, should be treated as a measurement tool because they can measure something. And because of that, I think it's appropriate to apply the methodology to machine learning models that we also apply to other models in psychology, namely validation methods. But how do we evaluate model performance? The authors that I just cited point to several problems. They say, well, the evaluation of a model's performance depends, among other things, on the research question pursued by means of the model in question. This raises actually a very interesting question that has recently been discussed in the philosophy of measurement, whether you can even get a kind of talk about the validity of a model outside a specific context. And what we're trying to get here is, does a particular model, is it valid kind of construct, does it have construct validity in general? There's a question of whether that's even a very good question, or whether we should always ask, is it a good model for this thing? There's also a second question, which is that if we we have different research that has used machine learning models, and we want to use them kind of for a meta-analytic study that evaluates machine learning methods. There's always a problem with meta-analyses, which is that the research that they're taken from papers that had different questions. So there's always the problem with meta-analytic aggregation. And lastly, there is a problematic practice in personality computing, namely over and under fitting. And this occurs when a machine learning model erroneously treats sample-specific noises as a signal or inadequately represents the underlying function. So it uses the data to extract certain information about an underlying factor, where in fact this is a result of using sample-specific noise in the data. So that the data, there's a lot of noise in these models, and the question is, how do we interpret the noise, and how do we get rid of the noise to get at the actual thing we want to get at, namely personality. Okay, so let me take a closer look at this question. Go right on. So one thing to highlight here, and it's probably, I mean, I'm hoping that this was clear earlier, but I would like to remind you that when researchers say that the machine learning models are, predict something, they're not actually predicting like people's behavior or anything. I mean, they're not predicting anything about personality. They're predicting the way in which they're predicting the result that a person would achieve on a quote-unquote real personality test. So let's say we give a standard Big 5 personality test to a bunch of people, and it comes up with a particular score, and then we give a bunch of, or it comes up with the Big 5, and we take machine learning data and feed it to an algorithm. It predicts those results. So it's not clear whether the machine learning models are actually models of personality. They're just models of how of the data, basically, that are generated by different means. Nonetheless, of course, the fact that it does come up with that these machine learning models come up with 5 factors points to the fact that they have a certain degree of convergent validity here. So we do have a convergence, and remember, the multi-trait, multi-method approach to construct validation says we want convergent validity, but it also says we want divergent validity. So the question is, we might still have that, and I'm going to read you a quote that kind of illustrates what I have in mind. Psychometrically, traditional personality tests attempt to minimize variance and construct irrelevant factors, meaning that test scores are as unaffected as possible by both systematic and random errors related to test administration, content, and test responding. By contrast, just as researchers hope to find personality-relevant variance in big data, there's also a massive suite of systematic and random irrelevancies that an algorithm can be trained on, leading to confounds we tend to call algorithmic bias. I'll talk more about this in a moment, but that, I think, is actually one of the most interesting questions here. So we get convergent validity, but there is a big issue here whether we have a method-specific artifacts, basically. So my claim here is that this issue can be diagnosed by, for example, by the statistical approach, the multi-trait, multi-method approach. How can it be diagnosed? Well, by establishing that by establishing that divergent validity is not very high. So we have convergent validity, but not divergent validity. That can be established statistically. But of course, this only can diagnose a problem, namely that that machine learning models don't have very, very high construct validity as of yet. Now, but my second point is, even if the method artifacts, such as caused by, for example, algorithmic bias, could be ruled out, personality computing models of the Big 5 would have similar limitations as traditional models, right? I mean, they would still not tell us much theoretically about what personality is. So in other words, I think the point still applies that McRae and Costa made in 1987. Theorists disagree on precisely how to conceptualize the factors themselves. So even if we could use machine learning models, and it looks like we probably, I mean, there might be methods, even though I'll talk about that in a moment, how we can increase divergent validity. But even so, the question is, what does that tell us about personality that we didn't already know? So this gets me to the last point of my talk, or the last section of my talk. Clearly what we want in research or in life is we want to find out more about personality. So we don't just want construct validation, we want construct development. And I'm quoting actually, sorry, thank you so much. I'm quoting a couple of very contemporary researchers who say pretty much the same thing that Costa and Cray said in 1987. We know very little about what aspects of personality MLPA models measure. So what else might we want to know? Well, this is actually an area where I'm really kind of, I'm to some extent saying what I myself think, but it's not so clear to me what we want to know. I think we probably want a fine-grained understanding of the specific ways in which traits manifest themselves in a variety of different circumstances, how these manifestations are systematically moderated by the populations from which we sample, how they relate to cognitive, emotional, and physical features of humans, and what kinds of predictions they allow. So these are the kinds of things we know, we want to know, and of course the question is what kind of conceptual development, what kind of theoretical development would we need for that, and what kind of research? It seems intuitively that one would probably want systematic control and variation of parameters informed by theoretical considerations, by hunches, by conceptual considerations. Now, the interesting thing about that is that it goes, of course, against a purely correlational approach because it requires people to actually think about what do we need to control here, what are we interested in, which population do we want to look at. And as a result, it actually goes very much against what many saw initially as the attraction of machine learning models, namely the notion that we could have a purely data-driven science of personality. And I think that's actually probably a very general point that I would like to suggest applies not just to personality research. But I think that there's this tension here. On the one hand, there's the availability of big data, and it's really exciting, and it allows us to maybe so the big data and the big data taken from real-world contexts. It allows us maybe to eliminate the specific theoretical biases of specific researchers, the specific research traditions people are in, and at the same time, I think it results in the problem that we just end up with this unfiltered mess and with these method-specific artifacts, and in order to figure out which ones might be method-specific artifacts, basically the human being has to come back in and engage at least in some amount of theoretical and conceptual speculation. Now, not surprisingly, perhaps psychologists tend to agree with me here, and this, I think, is, you have to also see I think there's a worry here that psychologists become superfluous, right? We don't, if the machine learning models can do all the research, who needs psychologists? So you have to take it with a grain of salt when psychologists say, clearly we're still needed, but I would tend to agree with them. I think they probably are still needed, but it also drives home maybe the point that research, if that's correct, research remains somehow a human-centered activity. So they've been arguing, this is literally in the last 5 years, that their special theoretical and methodological expertise is needed to push conceptual work forward. They emphasize that construct validity understood in this correlational sense is not enough. And they call for other validation methods to be brought to bear on personality computing. So they're not saying we shouldn't do personality computing at all, but they're basically saying this needs a little bit of human supervision. And in doing so, they mention other forms of validity, which I find really interesting because these are not I have to confess, notions of validity I had seen much before, so I think we're also really seeing the re-emergence of a very methodological and theoretical discourse within psychology. Again, probably you can't read this, but I'll just tell you what's on there to some extent. So they mentioned something they call substantive validity, structural validity. So on the left is like types of validity, and then they define them in the middle. This is just from one article. And then on the right, they give recommendations on what we should do to ensure that these kinds of validity can be achieved. So for example, substantive validity, they mention something they call content validity. And they define it as the degree to which a measure samples all of the content of a construct and none of the content of other constructs. Now, of course, this presupposes that you have a construct, a theoretical construct, and it also kind of presupposes that you already have an idea of how you're going to sample only those aspects of the construct. So in a certain way, I think we're right back at the problem of circularity here. But one of the things that they've been pushing, or that psychologists have been pushing, is we need more. Well, first of all, they say we need to examine the content of MLPA models, machine learning personality assessment models. It's not clear what that means. Distinguish between theory expected and theory unexpected content. So they're arguing for a notion of theory that needs to be at place here. But as I said earlier, part of the problem is that there really isn't a very strong theory, et cetera, et cetera. So I think this basically highlights the problem more than really giving a very precise solution, but I think it highlights a really interesting problem. And similarly with something they call structural validity, which they define in terms of reliability, generalizability, and factorial validity. And I'll just mention the first two. Reliability they define as the degree to which a measure produces consistent scores across forms, time and or raters. Now, of course, the problem is, well, with time, I guess, with machine learning models, I mean, this is such a moving target because the machine learning models also improve. But if you want to know whether the measure is consistent between different contexts, of course, the question is always, am I really sampling from the, well, it's a problem we've also discussed a bunch, some of us in the last few days. What am I learning about the about this model if I'm applying it to different contexts? Am I learning that personality is expressed differently in different contexts, or am I learning that maybe I'm sampling a different population and I wasn't aware of that? Same, of course, applies to generalizability. So the basic problem here is that a lot of conceptual and theoretical work needs to go into deciding, how you address these questions. And another, more on the practical side, the problem is, again, the issue or the attraction of machine learning models was that you get this huge amount of data that are not filtered. And now the solution to this problem is to filter the data, which to some extent then the question is, but then how do you use the data? Because the whole point of the data is that you don't know where they come from, right? I mean, they're like, so that's part of the problem. The other part of the problem is, but of course, so that's kind of one source, is the problem of algorithmic bias that I'd already mentioned before, which is, well, in a certain way, we do know where they come from. They come from social media use, which raises the question that not everybody uses social media. So there's already a selection bias in the data. So that this kind of illusion that we have just this kind of natural data just kind of being picked up by the machine learning methods, of course, is incorrect because the data don't occur naturally, they occur in specific contexts. So that's one issue. And one other issue, maybe one last issue that I wanted to bring up here is that even the people that tend to be active on social media might bring out particular behaviors in us that we don't exhibit in other contexts. So again, we have a problem of context specificity. Sorry, that occurs precisely because of the source of these specific data. Okay, so I've already jumped ahead of myself a little bit here. So I think there are problems of reliability and generalizability, and I don't mean to raise this like as a problem that is in principle cannot be solved. I'm just raising it as kind of to make you aware of the current situation, and also I think I would like to suggest that this problem in personality psychology is a larger problem that comes up in research context with big data generally. Data always need to be curated, and the question of how they're curated is as relevant elsewhere as it is here. And with that, I'm coming to the conclusion of my talk. Just to summarize, recent discussions within psychology highlight that the concern that psychologists have about personality computing mirror my concerns that I tried to explain by looking at debates about validity, about the limitations of purely correlational validation. There are suggestions in the literature that personality computing and personality psychology can be integrated, but they're still very programmatic. They reflect the sentiment that psychologists need to take the lead. I'm going to conclude by quoting from a recent article where the two authors say, "It is important that personality scientists assist in the interpretation of results in personality computing research to clarify what aspects of personality are being measured. But they should also participate in designing studies and data collection." As I said earlier, I think that's a really interesting suggestion, but it goes completely contrary to the idea that you don't need to design studies when you use these data models, and that's exactly why they were deemed attractive in the first place. And just to conclude, because I haven't said much about this, but I think the challenge in personality research, but I think also in philosophy, is to take a closer look at notions of theory and personality as used by psychologists. And the reason why I say it's also a challenge for philosophers is that I do actually believe that in cases like that, there ought to be, it's fruitful, and psychologists are currently also reaching out because they're really interested in having these more philosophical discussions. And with this, I would like to conclude. Thank you. I'll just go and sit with, should I sit with Anya? Yeah. Okay.
Hello. Well, hello everyone. Thank you, Uljana, for this amazing talk. I now will begin with this commentary. So I start. Along with this talk, Dr. Feest asked for the validity of the current machine learning models and big data methods to measure personality traits and how such technologies can contribute to the future development of the psychology of personality. Given the presence of machine learning models in assisting many scientific practices such as psychology, the question formulated concerns the status of personality computing as a tool for assessing what is known as the Big Five in the psychology of personality. A test that scores how individuals exhibit different personality features grouped in 5 significant factors, which are neuroticism, extraversion, openness to experience, agreeableness, and conscientiousness. In answering those questions, Feest gives us a historical characterization of how the psychology of personality evolved during the 20th century. In this context, she first describes how Jung distinguished personality into two types, extrovert and introvert, with other psychological functions that best characterize variations within those types. Then, Gordon Allport distinguished between types and traits, being the latter a more sweet way to describe differences across individuals. According to the author, types are classification devices, while traits are real attributes of people. However, given the problem that a huge amount of adjectives describe people's personalities in different ways, the question of how to reduce it to a more manageable list arose. That is, how the factor analysis and personality assessment emerged, in which a factor reduced data to a fewer number of underlying variables. A study conducted by Gilbert and Guilford in the 30th decade concludes that reducing personality to 5 factors was possible. But since the factor analysis method in personality traits was highly instrumental and used in many fields, the American Psychiatric Association began a study in the 50s to assess its validity. In that frame, Dr. Feest focuses on a particular notion of test validity, which is construct validity. This notion importance differs from, to say, predictive validity due to the need to not only predict the behavior of individuals in personality tests, but also to have an adequate theoretical construct of the attribute under the measure, whereas the data collected in the test are indicative of that attribute. Dr. Feest understands this notion of construct validity so that the construct can be viewed as a concept, whereas the trait or postulated attribute falls in the extension of the construct. The last calls for two related problems, construct and test validation. The former refers to the demonstration that a given construct corresponds to an actual attribute, whereas asks if the test measures the attribute described in the construct. To validate a test, we make an observation-based concept and then analyze the covariance between this observation with empirical data. Regarding construct validity, Feest says that the method used to establish it is primarily based on a correlational approach. Statistical methods are used to analyze data that fix or not in the construct in question, which refers to convergent and divergent variation. However, Feest believes we need a more profound understanding of personality traits and their underlying mechanism. Now, in the face of the problem of machine learning and big data to measure personality traits, the author says that, I will quote here, that technical fixes of the problem of method artifacts, as valuable as they may be, can only give us a better estimate of the convergence between two measures. As such, they can add to our confidence in the robustness of the Big Five, but they do little to help us understand the phenomena better, or to develop the construct of the Big Five personality traits in question. That means that that machine learning may enjoy construct validity, but not development validity, or the capacity to develop such a construct or a theoretical framework. But regarding the last, I want to raise some questions. The first one is that despite the fact that I am agree with the main intuition that psychologists need to be more profound effort in understanding or develop the construct validity of personality traits. Why not to embrace the possibility of include or think in other technology, another artificial AI-based technologies as data-driven technologies in order to assist professionals in psychology to develop such concepts, because those kind of systems has the capacity to create their own label for the data. And for other side, I think that machine learning has the big advantage of scalability, which means that insofar they can manage a large amount of data, they are very good in organizing and labeling those data, but what they can do, at least currently, is to develop a very sophisticated theory or concept. So I'm rephrasing this trip around my question. I repeat, why not think in another artificial system technologies? Another point that has caught my attention is that many theories that are occupied about the theme of technological unemployment, which refers to the possibility that technologies of machine learning could steal the job to persons, given its greater capacities. I simply think, how can we imagine a world in which artificial system in general, not just machine learning or data driving or etc., are doing all the job that are now currently doing. So I think that is a healthy way of thinking in the future of humanity, that psychologists, philosophers, and people that work in humanistic disciplines can defend their territory against the rise of the big data, the machine learning. So that's all on my part.
Thank you so much, Anya. I don't think I have very much to add to your questions. I think they're really interesting, and I'd like to talk more. I was intrigued, but I think the first one that you said, rather than we should also think about other AI-based models. I was thinking about data-driven technologies,
with I'm gonna give some definition first about machine learning and data driving to establish my point. Machine learning is not a technology that works in empty, because the data that are collected or the data which serves to train those models are pre-labeled by the hand of workers that are specifically dedicated to such tasks. And that, for other side, that the driven technologies are less demanding in so far they can read the patterns and the data without much need of labeling it. So I think it could be a good way of thinking about validity construct and validity construct development.
Yeah, that makes a lot of sense. And I think, to be honest, I'm still a little hazy on the technical details of the data they use and to what extent they're pre-labeled or to what extent then the results get labeled. So I think more than anything, I mean, obviously I'm not the psychologist, I'm not going to take, I don't have to take a suggestion of what I should do, but I should definitely, you're right, to look more closely at that whole process that I kind of hinted at the end. And where do the data even come from? Who labels them? And then what can be done? I mean, in terms of my suggestion, how can people kind of intervene in a theory-driven way, for example, or not? I mean, I think you're suggesting the opposite. But yeah, that's really interesting.
If neurotypical people are included, only neurotypical people, because sometimes we saw documentaries and I worked a lot with autistic people, and when talking about these 5 personality traits, it's very hard to include them in these 5 topics. So I was wondering if they were considered, if they are considered nowadays. And the second part is I was helping on a research in my last university in which we tried to talk about subjectivism in nonverbal autistic children. So we couldn't have the language as a verbal language as a tool, and trying to find out what was going on inside their minds. And we tried using mechanisms such as avatars and such, which are not well used in my country. So I was just curious because we have all this data and all these possibilities, and how then atypical people merge in this process. Thank you.
Thank you very much for the question. I hear several different really interesting topics there. The one is, of course, I don't know whether neuroatypical people are involved, because the data are completely decontextualized. But I would assume, insofar as many people use social media, they are, right? At the same time, I think you're raising also like two different questions. One is, it would be interesting to study that in isolation. That's kind of part of my point at the end was, well, it'd be nice to know which population you're sampling from. You could, find out much more. And lastly, I think you're raising an issue of, if we're going to use other machine based tools, maybe it would actually be useful to branch out and use other kinds of methods as well.
Yeah, well, thank you for the presentation first. And my question is, while researching, have you looked at the black boxes model, which most of the machine learning solutions are based on? Because when it comes to these models, we know what the inputs and the outputs are, but we don't know what's happening in between. Even their own developers don't know. So I think that sounds a little bit problematic. Any thoughts on that?
Yeah, I think that is problematic, and maybe that relates directly to the issue of theory, because machine learning models or deep learning models, that is precisely the issue, that you can't trace what exactly it did, and as such they can still be very good predictors, and in certain contexts that might be all we want. One question that I've been asking myself is, to what extent are these models they are predicting something, and so in a certain sense maybe they are models of personality, except if we can't explicate the model, that's not that helpful. And there's a big discussion actually in philosophy of AI going on about explainability. And I thought I was sidestepping the problem of explainability, because I thought I'm only interested in this as a tool. But I am coming increasingly to the conclusion that maybe I do need to face explainability, or at least the researchers need to face explainability, especially if they're confronting theoretical questions.
Hola. Okay, I have two questions as well. First of all, what would be the practical application of these models when you talk about this sort of machines? Are we talking about criminal profiling, mental health diagnosis, job interviews, or job personality assessments, whatever? And relating to that, this first question and what the person was saying just now, I forgot the word, sorry. What do you think would be like the new role of psychologists given this new development of technology? Because I think the preparation that psychologists usually have, 4 years of university, isn't exactly the one needed to operate these sorts of models, to regulate them, to use them thereafter. So we obviously are going to need some kind of specialization from psychologists. And at the same time, we are going to need the support from maybe other disciplines to help us develop these models and help us use them, given that I can imagine already, given the last questions or the uses they could have, there are many moral hazards that could be associated with using AI. So do you think psychology is going to take a technological turn, to say it some way? And maybe this is a third question, but do you think these machines are going to make psychology and hopefully, maybe utopianly, mental health care more accessible or less accessible, given that we will need specialized psychologists? Thank you.
Thank you for the question. I'm not sure I understood the last question, but maybe I can ask.
Okay, it was about the accessibility of psychology, because I'm thinking about the mental health aspect of things. And I think that if we have these models, we could hopefully, or I think technology it's made to make things more accessible, so more people have access, people with less resources. However, thinking about how psychologists are going to need more specialization, potentially more years of study, and potentially higher fees of education, being a psychologist is going to be more valuable and more expensive. I'm thinking if this sort of machine learning is going to make mental health accessibility more or less accessible for people, especially people in marginal economic situations and poorer people.
Okay, thank you. I'm still not sure about the last question, like where it's coming from, but let me just begin with the first two questions, or what I think I am understanding there. So you were asking what's the role of psychology, and you were also addressing like ethical issues, right? And I think the ethical issues come, and as you said, it relates directly to the previous question. They come from the fact that some decision is going to be made based on the recommendation of a technology that we don't really understand, yes, I think that is a real. That's definitely like one of the key issues I think of AI ethics right now. And so I'm glad you highlighted it, even though I was so much focused on the epistemological side of what is even personality and what are they measuring, that I wasn't touching that. But I don't actually have. One to me the interesting twist of this question is that the reason why AI models were initially hyped was precisely because the idea was you get the human bias out of it. Not so much, I'm not thinking mental health, even though there may be too, but in the criminal justice system, right, you don't have some judge who happens to be hungry because it's right before lunch and he doesn't like this person, and so they don't get probation or whatever. Rather, you have this machine that evaluates all the data, but then the problem is, what if this person wants to know why? Why they didn't, why they got the sentence they got. And then you can't explain it because you don't know how the system did it. So all I can say is agree wholeheartedly with you, and then the solution seems to be to bring the human back in. But even if the human is just going to say, I made that decision because I trust that system. I think it raises so many bigger issues that have to do with, we're going to be increasingly living with these systems. And like what kinds of relations of trust or distrust are we going to have with them? Now, the thing about the mental health accessibility, I'm still not quite sure how it got there, but maybe, right.
Thank you, Uljana, for your talk. It was really interesting and motivating. Just a brief question. I am very excited about the development of these digital techniques for doing psychological profiles, and I think that they probably will be very useful in developing this context-sensitive view of personality traits, precisely because of the reasons you mentioned, that perhaps in social media we behave differently than in real life, and also if the metaverse becomes something real, it probably will be a window to many aspects that we still don't know about personality. But I was thinking that about your notion of psychological kinds. I liked the way in which you, what we were talking yesterday, that you see that psychological kinds a very important part of these kinds is the social role they can play in how we understand ourselves and how we interact with others. So the social understanding of personality and other psychological kinds. And I was wondering whether you think it's possible that data-driven notions of personality could go in a different direction from the social first person and narrative conception of these very same personality concepts. And if you think that that could be problematic or no.
Thank you, Abel. So, in a way, I mean, the tradition of personality psychology that I presented today, the Big Five, there's a certain sense in which I think the machine learning models aren't doing, there's a certain sense, I'm not saying that there isn't, but in a certain sense, they're not doing anything qualitatively different. I mean, it is data-driven either way, it's kind of very, scientific, and this particular approach doesn't focus on the more social, the more personal, the more individual. So I'm not sure whether the machine learning per se is going to change. Somehow I think in our daily lives these kind of coexist. The whole the testing world coexists with a much more narrative understanding that maybe we have of ourselves privately, or even the narratives we construct around our Big Five. I mean, so yeah, I'm sorry, I don't think I have a much better answer, but it's certainly an interesting question to think about. Even like, why it is that we have these very different, that's one of the things that attract me to the personality, to the whole topic, is actually that on the one hand, personality is something that we think of as, we want a general theory of personality that somehow explains us. And at the same time, there's also a notion of personality as being something, everybody is unique. And historically, you can really see both strands of the uniqueness and how could you ever do a science of personality given that no person is like any other.
Thank you very much. Muchas gracias.
Thank you.